Alright guys, welcome back to another episode of Stonks Maxxing. Okay, I was about to say Intelligence Maxxing, that's a different one. But today, I want to spend some time learning about Elasticsearch and Snowflake. So those are two companies that reported earnings this week. I think are going to have a pretty substantial impact on this idea of software infrastructure for AI. Elasticsearch, they provide the Elastic Stack. One of the core parts of that stack is Elasticsearch, which I guess is a search engine and vector database that is really, I don't know what the right word is, but it's easily integrated with RAG pipelines and really any pipeline where you need to do a vector search across, say, word embeddings or tokens or embeddings of geospatial data. All of this stuff is very applicable to any artificial intelligence pipeline. So Elasticsearch provides a pretty strong software infrastructure for that. Snowflake, I think, operates as a data warehouse. So there's a data warehouse, data lake, database. All of these things are very similar. I'd say the differentiating factor is a data warehouse compared to a data lake. Data lake is storing structured, semi-structured, unstructured data. Data warehouse is storing semi-structured and structured data. So there's a bit more structure in these data warehouses. And also, it's not real time usually. What I mean by that is usually databases are connected to a website. It's a YouTube. I'm streaming on YouTube right now. I think after I stream, a new YouTube or live stream gets immediately uploaded onto the YouTube database. And then let's say every 2 hours or every 1 minute or every 30 seconds, the database is sending all of that data to a data warehouse or data lake. So data warehouse, data lake, they don't actually have real-time updates. It's usually in stages of time. With that, let's go in.
Good morning, good afternoon, and good evening, everyone.
15 minutes.
My name is George Kobar, Director of Product Marketing for Elasticsearch, and today we're going to be talking about getting started with Elasticsearch. Now, before we get started, I thought it would be fun if you could follow along with me while I do the demo portion of this webinar. If you're interested, I'll walk you through how to set up a trial account that only requires an email address. It should only take about 2 minutes. But if you rather listen or you're just not by your computer, that's okay. Just sit back and relax and we'll jump into the slides in the next 2 minutes. To start a free trial, you can go to this link, which is ela.st/gt-strd or getting started. Or you can go to the registration page and there should be a link that says start free trial there. Again, there's no credit card required, just an email address. And when you press that link, you should now be presented with metrics, logs, and traces. You can select observability. If you're looking to use Elastic for security or securing your infrastructure, you can do that. Or you want to look for something else for different use cases, that's listed here. And I'm going to learn more about Elastic, so I'm going to neselect that. I'm going to go ahead and press next.
Okay, search.
Okay, and I'm going to go ahead and name my deployment. I'm going to say getting started with Elasticsearch. And notice that we're going to deploy this environment to Google Cloud in the Iowa region. If you want to go ahead and change that, you can hit Edit Settings, and you can pick between the three cloud providers currently: Google Cloud, AWS, or Azure. And of course, based on that, you can look at the different regions that we have available. Pick a region that's closest to you, and we have different storage profiles, either optimized or optimized dense or general purpose. And for our sake, we'll just go ahead and do general purpose. And I would always recommend picking out the latest version. So I'm going to go ahead and hit Create Deployment. And what we could do is, once we approach the screen, we can go ahead and download the password, just so we have those credentials if we happen to get logged out. And while this is loading here, it'll take about 5 minutes. Let me go ahead and talk to you about who Elastic is. So while that trial is being set up, let's just dive right in. So whether you're looking for rides, looking for food, or looking for love, Elasticsearch is the technology behind these search applications. Elasticsearch is behind a lot of other great applications that use a search. If you're searching through logs, metrics, security events, traces, telemetry data, or if you find if there's a website with a search bar in it, there's a good chance it's Elasticsearch.
Okay, that's cool.
And we all expect to be able to find the information we need when we need it, and of course in real time. But a lot of this information we're looking for, like ourselves, our customers, our employees, it's everywhere. And it lives in websites, applications, knowledge bases, on file share systems, data spread everywhere. And that's why one of the solutions that Elastic has created is enabling you to be able to search everything anywhere in real time. And thanks to an accelerating pace of technology, change, enterprise IT, applications, infrastructure, data is becoming more and more complex and more abundant.
This is mean time.
And it's
to recover.
exponentially increasing. We know that developers, administrators, architects require these tools to help them increasingly complex digital ecosystems to make sure they're both available and performant. And given the increasing customer and employee expectations, downtime and poor performance can also be costly. That is also why Elastic for Observability enables you to monitor and react to these events happening anywhere, and in turn, streamline your observability for your entire digital ecosystem. And given exponential data growth, security analysts require tools that enable them to protect ever-growing attack surfaces. Consider how a single security incident can impact both customers' trust and, of course, the bottom line. And that's why Elastic for Security.
I think one thing to think about is, I guess there is this idea of, okay, can these large language models, if trained on the right data, just eliminate the need for search? I think that's something to think about. Because LLMs are effectively a search engine, right?
Security enables you to prevent, detect, and respond to complex cyber threats at scale. So the Elasticsearch platform is the best platform for enterprise search, observability, security, and a lot of other great use cases. It adds tremendous value, and of course across industries, geographies, and segments. From technology to finance to telco, healthcare, Elasticsearch is helping the world's leading business accelerate results that matter. And this is the technology stack that powers these use cases and solutions. You may have heard of the Elk stack or Elastic stack, but what is it? Well, for starters, they are one and the same, which Elastic has created as a single technology stack or data analytics platform that enables search-powered use cases. So the stack comprises of integrations. Integrations which gives you the flexibility and use of a variety of methods of bringing and ingesting data into the Elastic Stack. So you can connect at scale, explore your data with turnkey integrations for cloud-native infrastructure, applications, security events, all from a single intuitive UI. So the integrations are a single intuitive of many different components.
Okay. Elastic. Elk. Kibana, Elasticsearch, and integrations. This L is for Logstash and Beats. Okay. I'm gonna put in the Elk Elastic Stack. So log stash and beats are integrations. Yeah, so Elastic Stack is one stack to store, search, and analyze. Okay, I guess Kibana is probably the vector database.
You could bring data into the Elastic Stack with our language clients or Elastic Agent. Or, of course, if it happens to be residing on a large cloud provider, we have a lot of cloud native solutions.
Okay, so data can be integrated, software can be integrated through client languages. So this is basically coding up an app that uses the Elastic Stack library. Or integrations with cloud providers, so AWS, GCP, or Azure.
Of course, Beats and Logstash. There's a lot of options of bringing data into Elastic. So these easily ingest to put your data to work with these turnkey integrations from any data source or any format, including if it's structured or unstructured data. So you can easily get visibility within seconds with these pre-built dashboards for logs, metrics, security, APM, uptime, and much more. And we manage all of these lightweight data shippers called agents from a single UI. Next in the stack is Elastic called agents from a single UI.
Okay.
Next in the stack is
shipping data. In the webinar, they called this shipping data. So how do you get the data into the Elastic platform?
Elasticsearch, which of course you've come to learn about. Well, Elasticsearch is a near real-time distributed RESTful search engine and analytics engine that's really capable of addressing a growing number of use cases. So as the heart of the Elastic Stack, it centrally and securely stores all of your data for lightning-fast search, fine-tuned relevancy, and powerful analytics that scales with ease. So Elasticsearch is built for blazing fast search for any data type. Again, structured or unstructured or geospatial data. Elasticsearch is put together to tackle any of these, any use case that you have. So it scales horizontally and can handle cajillions of events per second while automatically managing queries distributed across clusters for smooth operations. And of course, part of the searching piece, you could rank based on a variety of factors, from term frequency, recency, popularity, and of course, we'll go through this a little bit more within the demo here. So we're going to go over the last component first, and then we'll dive right into Elasticsearch. And that last component of the software stack is Kibana. So Kibana is the front-end application of the Elastic Stack, and first and foremost is really the home for a lot of Elastic's turnkey solutions. And it's the UI you use to analyze and visualize this data for all of these use cases. It's a central pane of glass for all the data you keep in Elastic Stack, and also provides a central place to manage the stack. So Kibana also has advanced analytic capabilities to visualize and explore your data. This helps you accelerate insights using geospatial analytics, machine learning, and all other capabilities that will take your analysis further, especially within time series data or any data. So Kibana has a customizable dashboards that offer collaboration tools that help you share your investigation findings with your team, and organizations via visualization, metrics, and more. So there's a lot of great visual elements within Kibana that really helps drive data analysis and insights. Okay, now that we've covered who Elastic is, our turnkey solutions are, and what comprises of the Elastic or ELK stack, let's go ahead and learn more about the fundamentals of Elasticsearch. So Elasticsearch, as mentioned before, is a search and data analytics engine, which utilizes an open search engine library called Lucene.
Okay, so search. So Elasticsearch is this is the search and analytics engine as part of the Elk stack. Okay. So technology-wise, it's built on top of Lucene.
Both which are written in Java. Engine library search and data analytics engine, which utilizes an open search engine library called Lucene. Both which are written
On top of open, wait.
Search, as mentioned before, is a search and data analytics engine, which utilizes an open search engine library called Lucene. Both which are written in Java.
Open search? I'm not too sure what that means. So, written in Java, so is Elasticsearch.
So a node is a single instance of Elasticsearch. And you have the flexibility to install this node or this single instance of Elasticsearch directly on hardware, virtual machines, containers, or within the cloud. Now, a cluster is formed when we have one or more nodes. So each Elasticsearch can scale as more nodes are added to the cluster, and it can scale to the hundreds of nodes. You can also search across many Elasticsearch clusters that are geographically separated. Not only can you search this data, but you also can replicate this data from one cluster to another. And it doesn't matter how you're...
So, okay. The most basic unit on Elasticsearch is the idea of a node. This is a single instance. So I feel like this could be a similar idea to Kubernetes. You have these pods. I think Kubernetes is used to control containers or instances of an application, I want to say, on a cloud environment. Yeah. Like, I don't think AWS does that unless Kubernetes is open source. Deploying and scaling containerized applications. Okay. Be similar to a, I think it could be pod. Most basic unit, okay. One container in Kubernetes. Maybe it could be the idea of I'm trying to find the parallel. I would maybe say node could be a pod, or it could just be a container. Or possibly a container. Or just a container. Okay. I saw my wrist, I saw my teeth, damn it. Okay. So a cluster is a collection of nodes.
searching across these clusters. One cluster could be located in the cloud. Another.
Okay, so Elasticsearch, can search across clusters even if they are located on different platforms. So cloud, hybrid, or on-prem.
Another in another cloud, or one with on-premise or in a hybrid configuration. No matter where your Elasticsearch clusters are, they could be searched and replicated. And stored on Elasticsearch are documents. A document is a serialized JSON object that is stored in Elasticsearch under a unique document ID. And we mentioned too, this could also be structured or unstructured data. So let's think about a table that contains rows like blog titles, release dates, author names. Well, this document really consists of fields and values, which is easily converted into a JSON object. So in Elasticsearch, a document is indexed into an index. And an index is a logical way of grouping similar type data. So some indices is organized by time and data type. So if you
So indexed or just grouped into an index. This is just a collection of similar documents. Why do I have to make it so confusing? I'm very tired. I'm going to close my eyes for a little bit, 'cause I'm very tired right now. Alright, didn't even start, did I? Okay, I am started. I have started. I'm so tired. Okay, I'm gonna I am going to take a nap. Take a very, very, very quick nap. Minutes. Just shut my eyes for 15 minutes. Oh, God. 3 more minutes. Oh, alright. Indexing, that's where we were on. Alright. Yes, I need to bring my charger. Oh god. Bring it. Okay. My legs are so cooked from squatting and deadlift. Okay. So, what did we go over so far? Elastic Stack, the Elk stack, Elasticsearch, Kibana, which is the UI, and then the integrations, which are client integrations, client language integrations. So you could use Java, C++, PHP. There's also cloud integrations, AWS, Google Cloud, Microsoft Azure, and then there's integrations Bean or Boot and Logstack. So I think that's with logs. If you want to look how your application is, I would say logs are probably performing, or events that happen. Like someone visits your website, or you need to make an API request, something like that. And then the underlying tech stack. So you have nodes. Nodes are the most basic unit. It's an instance of Elasticsearch, and then cluster is kind of a level above that. You have a bunch of nodes that creates a cluster. Okay. And indexes. So indexes are ways of grouping similar documents together. A cluster. All documents are in a are grouped. Next. Throughput, okay. Oh, shard. Alright, well, I'm going to probably, it's probably this idea of a shard that will come up later. I'm looking on some images online from my other computer, but I'm gonna just do this and then
You think of logs or metrics or any types of time series data, you'll have one index for logs, and let's say for Monday's logs, and you'll have another index for Tuesday's logs. And you might have another index for metrics for Monday or Tuesday. but you'll be able to easily search across these indices. So let's go back to the cluster diagram. We can see an index is stored within Elasticsearch node. And indices can span the entire cluster, and the documents stored within them in Elasticsearch are distributed across the nodes.
Okay.
But when you look closer at an index, the documents are really stored on an object that we call a shard.
Okay, so indexes can span across clusters, across the cluster. Different nodes. This can be served by index touching, I don't know if touching is the right word, touching all of the nodes.
And a shard is an instance of Lucene contains all the data of one document.
Inside an index, there exists another unit called shard. Okay. Okay. So shards are, oops. Instances of Lucene contains all the data of any one document. Okay.
So it's shown here you can distribute shards across the cluster within an index.
Okay, so shards can also be distributed across an index. Nodes.
So this index has a total of 5 shards, and every shard holds 20% of the documents in this.
Multiple documents.
This index. So what happens when we lose Elasticsearch node or duplicate? We would lose data. So that is why we have 2 types of shards. A primary shard holds the original data of the index, while the replica shards has copies of the primary shard.
Okay. There are 2 types of shards. Primary shard and a replica shard. So primary shard is the original shard of an index. Replica shard is copies. Okay, so are copies of the primary shard, right?
If we lose one node in this configuration, the replica shard becomes a primary and starts to replicate the data to a new shard on a new node. So primary 1 on node 2 will also replicate a shard on node 3. Primary.
Okay, so primary 1 on node 2 will also replicate a shard on node 3. So you have this replica shard becomes a primary
One
shard.
on node 2 will also replicate a shard on node 3. Not only do you get the benefit of data resiliency, but you also get the benefits of write scalability.
Okay. Okay, maybe I'll create a section here, like what's with all the shards? What's with all shards? Right, because it's a bit confusing. Or use there so that one node gets killed off, the data stored in the shard won't. Primary and replica shards are there, so this not also doesn't get killed off along with the primary shard. Sure doesn't kill off, the data doesn't get killed off the node. Okay. All right.
As data is being written to all 3 nodes on primary shards, and read scalability, as all replicas shards can be used to answer a query. So you're sending a search, the primary or replica shard can answer that query. So there are some trade-offs. Obviously, more replica shards means there's more data storage, and more shards uses more resources like CPU and memory.
CPU and memory.
Well, one of the ways we can get around that is what was called by storing your replica shards onto object-based storage. So effectively reducing the storage cost by half. All of your primary shards are on your Elasticsearch node, which responds to quick queries. And if there happens to be an incident, the replica shards, your cluster will be able to go to replica shards that are stored on object storage like S3, Azure Blob Storage, or Google Cloud Storage, and that data is backed up. Now, there's also an opportunity, let's say if you wanted to entirely store this shard data onto object storage. So you don't want to have anything stored on local SSD drives, for example, but you might want to have the data stored directly on S3. That's also another configuration that drastically reduces your storage spend and is pretty performant. So Elasticsearch can easily be used by any language. Java, .NET, PHP, Ruby, Perl, whatever you want. And a lot of those clients are listed, so you can see if your language is there. But it enables you to write applications in any language, and you can use any language client to interact with Elasticsearch. Let's go ahead and do a quick review. So a node is a single instance of Elasticsearch. A cluster is a collection of these nodes.
Okay, so that's actually pretty helpful. Fundamentals of Elastic.
Working together, distributed. And of course, a cluster can reside in multiple geographic locations. An index is a container for documents within a cluster and consists of shards. And I would also like to consider a shard a unit of work, which also means that if you have too many shards and not enough resources, that could also negatively impact Elasticsearch. And a document is really a data structure to store information JSON, which belongs in an index. All right, so let's go ahead and go over a brief installation. If you were to install it on-prem, so if you're doing on self-hosted, you can install this as a Java process, meaning you can use whatever packages you want, like for example, Yum, Zipper, apt-get. You can also install this as a virtual machine or on containers. And of course, we have Elastic Cloud, which is our Elasticsearch as a service. And at the very beginning of this is what we did a quick trial account. That's what we're going to be using as Elastic Cloud. And of course, we also have the Elastic Stack as a service within your data center. So if you want to serve up multiple Elasticsearch clusters within your environment, you have that ability. And we also written a Kubernetes operator, which is for ECK. And the installation and start for self-hosted, for example, this is just a quick example of doing a wget, and then also unzipping, or excuse me, tarring the contents of the Elasticsearch instance here. And then we're going to do /bin to start. For Windows, you're going to do run the .bat file, and you also want to run Kibana. And then if you're going to install Elasticsearch locally, I highly recommend.
I keep forgetting like what's a .tar in a zip file.
Do it as a container. You can do that I would recommend Elasticsearch and Kibana together. Okay, let's go ahead and start our demo time. Looks like an environment's ready to go. And you should be presented with a welcome to Elastic, so we can go ahead and add integrations or just explore on your own. And the data we're going to be used today is on the registration page. So I'm going to hit explore my own. And the first thing we're going to do is we're going to come to this hamburger menu over on the top left-hand side. And we're going to come down to the very bottom here, which is called Dev Tools. And this is just a place where we can enter in the our REST API calls. If you want to use another client to do so, like Postman, you're more welcome to do that. So I'm going to go ahead and hit dismiss here, and I'm just going to go ahead and delete everything. On the registration page, you'll find a file that says demo script. We're going to open that up, copy the contents, and paste it here. Okay, so from the registration page, I downloaded that file, demo script, locally to my desktop. And what I'm going to do is I'm just going to select all the contents of this and just copy, go back over to the Kibana in the Dev console, and I'm just going to paste all of it here. And I'm going to go ahead and scroll up. Oops. Scroll up to the very top. Perfect. And this is the script that we're going to be using during through the demo section, I should say. So feel free to follow along. And of course, what we're going to do is a lot of CRUD operations. We're going to search, index documents, look at indexing, mapping. And Elasticsearch has so many different capabilities, or so many different APIs. It'll be impossible for me to go through all of them within an amount of time that will be good. So I will plan on doing a lot more, going through a lot of the search APIs, or a lot of my colleagues who are going to be doing this well. But I feel that most of this is going to be a good foundation to kind of get your feet wet and get started with Elasticsearch. So let's jump right into it. So really what we're looking at here is the Kibana Dev Console. We're going to use this to interact with Elasticsearch. So we talked about what a document is inside Elasticsearch. It could be unstructured or structured data.
Okay.
But typically it's a JSON document. They're keyword and a value. And each value has to be one of the 6 types that are to be a valid JSON. For example, string, number, object, array, boolean, null. You can find all that information here at www.json.org. So let's go ahead and index our first document. So as we mentioned before, when we say index, that means we're actually taking a document and storing in Elasticsearch. So we use that as a noun and an adjective. And we're putting a document in Elasticsearch and storing it. And we're going to be using different types of data throughout this demo. And you'll find that on the registration page too. One of the files you also will need is 2019 Michelin restaurants. So Michelin, if you're not aware, they do ratings of different restaurants. And I like this data set because inside the file, the data itself, it has a lot of unique attributes that I think really lends itself to a great demo, or at least getting started with Elasticsearch. Well, actually, let's index our first document and let's take a look at what's inside this data. So this first API command here, if we take a look, is a post command. And the next, right beside, or just to the right of the post, we see Michelin. And that's the name that I'm giving my name to this index. So this is arbitrary, but for the demo, we want to make sure we keep Michelin, because I think there's a lot of commands that that are based on that index name. But for example, if you want to change it to restaurants or whatever, if you want to kind of play with yourself, absolutely you could do that. But this is kind of arbitrary to me. But to the right of that, we see _doc, and that's letting Elasticsearch know that we're going to index a document into this index called Michelin. And we actually take a look at the document, we could see the actual Michelin data. The year that Michelin rated this restaurant, some cool geospatial data, some latitude, longitude, the city it's located, the region, zip code, the cuisine type, how expensive the restaurant is, URL, and what Michelin rated this restaurant. So for this particular restaurant, they rated it as a 1. So I'm going to go ahead and come over to this little triangle here, and I'm going to go ahead and send that request. And on the right-hand side of Kibana DevTools, you'll see this is the response that we got. Okay. So we see that, yeah.
So this is them creating this index, Michelin doc, all of these fields, and this is the new index that they've created. The response.
Yeah, we actually have an index now.
Okay, so clusters need to get Elasticsearch work. Excuse me, clusters need to be deployed, communicated with communication in applications and the cluster happen with RESTful so send a post request to create an index on the cluster, right?
Called Michelin, and this is the document ID that we just ingested. This is dynamically created by Elasticsearch. Result was created and it was successful. So now what we're going to do is we're going to come down over and we're going to search this. We'll be sending a get command to the index and _search. So let's and if I execute that, you'll see it took less than a millisecond here. And we can see that query was successful. And we're searching the index of Michelin. And this is the only document within this index. So that's why we're only receiving one document there. And it's exactly what we ingested into Elasticsearch. So we're going to dive into the Search API soon. But we're going to focus on indexing documents. Elasticsearch uses the REST API, and it matters between if we do a post versus a put. So if you do a put and we try to do the same thing what we did as a post, we'll get an error message. Elasticsearch is expecting if you don't specify the document is a post. So this is a new restaurant. We're just going to go ahead and add this data to Elasticsearch, and that was successful. And notice though, if we choose down on line 121, if we specify put and we specify the document ID, so this is the index /_doc / the document ID, we're specifying 1, 2, 3, 4, 5. We're choosing, we're going to put this one to Elasticsearch, and that is successful. One thing that we haven't really talked about yet.
Probably spend maybe 4 more minutes on this. So ended around 24. Ended webinar at 24 minutes. So continue from there. Oops.
Is not be red shoes by be red sneakers. So there's a lot of other relevancy that the web search is going to provide you. It's the same thing with Elasticsearch. It's going to provide you what it thinks is the best hit, and then also the subsequent that has a high score as well. So if you want to find some more information on how to you expect from a SQL output, ordering by star type and descending order and limited by 500. So you can see here a lot of restaurants are rated through their mapping. So then as you're ingesting data, it says, oh, this type of data is geodata. Calling this template called my dynamic index. But for example, if you want to have any new index that comes up, you can do, like, for example, index star. So if you say my index template star 1, it'll apply this template to it. So anyway, hopefully that makes sense. What I'm going to do is I'm going to go ahead and create this template. That means any new templates that come up that fit this prefix here, it'll actually apply that mapping on there. So yeah, in this mapping, we've specified a new field that is unexpected into discrete tokens. So what we're going to do is we're going to go back to our go back to our Michelin data, and we're just going to analyze this. And notice that the text, we're using a standard tokenizer, and we're going to present the text, my email address is test123@company.com. So I'm going to run that. And the analyzer, the standard tokenizer, is going to analyze this text that we just put in, and notice that it's broken every single word out as a separate token. So it's going to search my email address, test123, and company.com. So if we also look at using the tokenizer for white space, it's going to identify all of the white spaces. Like, it's going to set the start and the end offset. So it's going to look at that same text that we put in, my email address, test123@company.com, and it's going to identify where all those white spaces are within that specific text. And we're going to also, using the standard tokenizer, and we're going to do brown fox, brown dog. Let's go ahead and analyze that.
That was Elasticsearch. So 40 gigabytes of storage, 1 gigabyte RAM, up to 2.5 of vCPU. Not too sure what that means. Store less frequently, query data on a warm tier for increased cost savings. 1 gigabyte RAM, up to 8 vCPU. Hourly rate. So about 5 cents an hour. So it seems like it's consumption based. Times 24 times 265. $460. 90 terabytes of storage. Times 24 times 265. Okay, so that could be like 1 million. Who needs 90 terabytes of storage? I guess if you're a massive company, that's probably where the money really comes in. 90 terabytes, you probably need petabytes of data. Right. I think as data scales, maybe as data scales, these consumption-based. It's actually a good question. Like, I feel like big data was a big thing, right? Big data. So when was this invented? Okay, I'm gonna go in this thing again. So I think Elastic's pricing model, consumption-based pricing model is interesting because as the organization client scales, their data scales, consumption scales, right? So you have this self-reinforcing loop where if the company is using Elasticsearch, they get bigger, they need to ingest more data, then the consumption increases. That's how you could really earn money. Okay, so pricing model. Consumption. On hardware. Okay, so you have Kibana, your integration server, enterprise search. This is all on Google Cloud. Okay, yeah, I'm gonna use the bathroom real quick. Gonna put on my vest. Gonna put on my vest. Oh, alright. The do they run a cost plus pricing scheme? So cost plus pricing scheme for their cloud business, right? So they charge, could be they need to pay cloud providers hosting deployments of Elasticsearch. Okay. Well, actually, there's a lot of deployments, not just Elasticsearch, but integration server. Will charge clients a fixed percent top of that. Deployments for a cloud deployments for Elk stack, the Elastic stack. Okay. Oops. Do not want that again. Also, what is this Lumen thing? Right, Lucene, right? Apache Lucene. So Lucene indexing. This is what a single index is part of, right? I think this is a shard. So this is what a shard is. Query, index searcher, index writer, Lucene directory. Okay. It's cool. All right. So that's sort of use case caches. Iowa. So location also changes too. Let's see if so Google Cloud is cheaper. AWS ranks as the most expensive. APM, app search. Okay. Three. The pricing table. There are 2 ways to affect the 3 ways to increase, decrease the price per hour. So one is choosing a data center geography. Actually, the first is choosing the cloud provider. So AWS is greater than cost for AWS greater than the cost for Azure, which is greater than the cost of Google Cloud. So Iowa, VA, etc. Can you do this internationally? Oops. Forgot that was a screenshot. Oh yeah, you can. Okay. Is there a China? There's a Taiwan. Taiwan, etc. Choosing the tier standard, gold, platinum, enterprise. Okay. Cloud serverless. I don't know what this is, to be honest. Vector search optimized, vector search. So maybe they also sell serverless products. Not sure what this is. Oops. Application performance monitoring agents. Okay. So yeah, it's something slightly different. You know, now that I have time, it would be helpful to also like take a look at Snowflake. I know we had talked about that. Snowflake. Let's see. So data warehousing, cloud-based data warehousing. Software used by business analysts and data scientists for business. Okay, well, for data analytics, how about that? Okay. I was hoping they have a video to watch. A live demo. Oh, wait. Okay, so this is also consumption based. I think anything cloud related is probably going to be consumption based then. Because these guys, I think, so I'm trying to think here. It is also consumption based usually because the underlying cost structure of Snowflake is consumption based. But I think what I mean by that is Snowflake is deployed on AWS, Google Cloud, or Azure. So intrinsically within the company, they have to spend money to actually deploy it on a server or a cloud server. So if Snowflake were to charge their customers some type of fixed pricing that doesn't change based on consumption, there's a chance that the customer uses a lot more resources than the fixed cost could cover. And so that would mean Snowflake would just have to eat the rest of the costs, right? I think an example is, let's say you sell a contract for $100 to Netflix. AWS, they charge Snowflake $1 per hour. I'll call it actually $1 per day to make this easier. So they charge Snowflake $1 per day to run their platform. And this 1-year contract is for $100. That would mean that Snowflake would be operating at a loss if they're selling this 1-year contract to Netflix for $100, and it costs Snowflake $1 to run every single day. Sometimes it could be $2 too. So that's why that's a bad example, and it's hard for me to explain it well. This is a good skill. Okay, what's a better way to explain it? So starting from the top again, you have contract between Netflix and Snowflake selling this data warehouse for $100, and the contract is 1 year. Then you have the relationship between Snowflake and AWS. There is no contract. That's completely consumption based. But let's say, for the sake of this example, you're consuming $1 per day on AWS. Then Netflix will only be paying $100. But Snowflake, they have to use $365 worth of cloud resources in order to actually provide the service to Netflix. So while Snowflake earns $100 from that contract, they still have to pay for the extra $265 that they are going to consume from AWS. So in order to make that work, Snowflake can go back to Netflix and say, hey, instead of paying us $100 per year, you're going to pay us you're going to pay us $2 for every day of consumption for every day of consumption. So now you're earning a guaranteed $1 of profit. I think that's probably how it could work. Yeah, man, why is this so complicated? Okay. Snowflake developers.
All right, so listen up. State Farm was trying to charge me $197 for car insurance. No, thank you. I got a friend who told
columns. One is V, and this holds the entire.
This is my hack for working smart, Monday.com. Let me show you how I use Monday.com to create a tailor-made.
Thank you for joining us today for this demo of Snowflake's UI. My name is Peter Mebin, and I'm a sales engineer here at Snowflake. Snowflake's platform enables a number of different workloads for users on top of any of the 3 major clouds. We believe that you should have one platform where you can store all of your data, regardless of its structure, where you can provide managed, secure access to it, and leverage the unlimited scale of the cloud.
So they sit. This would be a good picture to. Snowflake's selling point can be integrated on all cloud platforms, not just limited to AWS, Azure, or GCP. I feel like that's something I was always wondering. Like, I feel like AWS probably has a data warehouse for any of their EC2 instances, or data warehouse for any project or application that a company is trying to build. I guess Snowflake's argument to that is, okay, well, what if that application, you could store that on AWS, Google, Azure, instead of having multiple warehouses for applications across platforms, you can sort of unify that and on the Snowflake platform. Depends on AWS, Azure, GCP. There is no need to have multiple data platforms for each cloud warehouses for each cloud platform. Snowflake can aggregate it into one. One central platform.
Finally, we believe you should be able to do all of this without having to manage infrastructure, so that you are only focused on getting value out of your data. On top of the technological benefits that Snowflake provides, the idea of the data cloud is really the idea that value in Snowflake comes from the content that you get access to as a Snowflake customer. Because data sharing is so easy in Snowflake, you can not only monetize your data through the data marketplace, but you can bring in external data to enrich your internal data sets without having to manage FTPs or go to cloud buckets. You can get all of this data live from the providers with minimal management. In this demo today, I'm going to give you a brief tour of the UI. I'll show you how to load data into Snowflake. We'll talk about scaling compute warehouses. We'll also briefly touch on semi-structured data and how you can query that in Snowflake. We'll talk about our data marketplace and overall data sharing features. Then we'll briefly touch on creating visualizations and dashboards in the Snowflake UI. The data we'll be dealing with today is City Bike data. City Bike is a bike sharing service. We're going to be focused on data in New York City, and the data we'll be dealing with is about trips and stations. We're also going to bring in some of our own weather data to augment these data sets. In the Snowflake UI, you can see that I'm signed in with a DBA City Bike role. I'll go through these tabs here. The first is the Worksheets tab, and we'll get into what a worksheet is a little bit in a second.
Okay. So in theory, city bike data as sample on YouTube. Oh, I think I can watch my own stream. The hell? Hey, I can watch my own stream. Okay, that's cool. Okay, Snowflake 8-minute demo. How is that?
Thank you for joining us today for this demo of Snowflake's UI. My name is Peter Mebin, and I'm a sales engineer here at Snowflake.
Okay, Snowflake platform. So I'm watching on 2 devices right now, actually. This is gonna be interesting.
We've got dashboards, which we'll also talk about later. Under the data tab, you can see your databases, and you can drill into these further to see schemas, tables, views, etc.
Okay.
This is
Home page, dashboard. Snowflake comes with a dashboard-like UI where you can control all parts of the data warehouse. So you have worksheets, dashboards, data sources.
This is also where you'll get access to the data marketplace. The compute.
Oh, compute. Okay.
Compute tab is where you're going to manage your warehouses. So at Snowflake, we separate storage and compute. Compute is what's actually doing the work on your data, whether it's loading it or transforming it or querying it. When you create a warehouse, you'll give it a name.
Manage.
Then you're going to choose the size. An extra small is a 1-node cluster, and you'll see that with each step up, the number of resources doubles. Snowflake charges per second. So if you have an extra small one, create a warehouse, you'll give it a name. So at Snowflake, we separate storage and compute. Compute
Oh, actually, let me.
is what's actually doing.
Snowflake separates How are my options doing? How are my options doing? Okay. Snowflake separates data and compute. The compute section of the UI houses the allows users to manage the amounts of resources used.
The work on your data, whether it's loading it, transforming it, or querying it. When you create a warehouse, you'll give it a name, and you're going to choose the size. An extra small is a one node cluster, and you'll see that with each step up, the number of resources doubles. Snowflake charges per second, so if you have an extra small running for 1 hour, you will see that it consumes 1 credit. We also have multi-cluster warehouse. In this situation, Snowflake will start off with 1 extra large warehouse. As users sign into the system and start using this warehouse, we don't want there to be resource contention and a degradation of performance for those users. With multi-cluster warehouse, Snowflake will automatically spin up an identical extra large cluster and balance the queries between the two. It can do this up until 10 clusters so that end users see no degradation of performance regardless of how many users are accessing that warehouse at the same time. And just as Snowflake automatically scales out, it will scale back in when those resources are no longer needed so that you aren't paying for them unless that they are being used.
Okay, that's cool.
Let's get into the demo. We're going to start off by loading some trips data. So I've set up a stage where I've staged 232 CSV files. We'll see that this data as a whole represents about 2.2 gigabytes of compressed storage. I'm going to create a table for this to land in, and I'm going to go ahead and start copying data into this table. You'll notice that I'm only copying data from 2020. And if I look at my warehouse size, my load warehouse is a small. So we'll see that we loaded 40 files in about 12 seconds. This equates to about 20 million rows. But if you remember, I had 232 or 242 files in that stage. And I don't want to wait for all of those to load. So you can see within seconds, I scaled this up to a large warehouse. So I went from a small to a large, which is a 4x increase in compute resources. Now I can copy in the rest of the data, and you should see that it runs in about the same time, maybe a little bit longer. And we're going to load in the remaining 192 files that were in that stage. There we go. We can see we loaded 192 files in 13 seconds. Now that I'm done with that, I can scale the warehouse back down to a small because I don't need the large resources anymore. We see that I now have about 116 million rows in this table. And if we take a look at the data, it's just data about the trips. So how long?
All right. So that's actually a cool feature to have, like the scaling. Scaling of resources. Resource scaling. Compute resource scaling for larger, more intensive workloads and smaller, less intensive workloads, right? Compilation, files, execution.
How long they took and where and when they started and stopped. I've also got stations data that I've already loaded in, and I've got weather data. And what's interesting about this table is it only has 2 columns. One is V, and this holds the entire JSON file for this weather record. But what's really interesting in Snowflake is I can use basic SQL to query this. So using a simple dot notation, or I'm saying go to the V column, go find the city key, find the name key, and then cast that value as a string, I can start pulling data out of this JSON file without actually changing the underlying file at all. Now I'm going to go ahead and I'm going to change my warehouse to an extra large, and I'm going to build a view that combines the trips data and the stations data together. We can see that now, instead of just having the station ID, we have information about where the stations are. And now I can add in my weather data. And again, this data is still stored in its native JSON format, but I can pull out the values I need into this view with basic SQL syntax. So if I scroll over, we see we still have our trips and stations data, but now we're also pulling in weather data, even though we haven't changed anything about the data as it's stored in Snowflake. What we could also do is we could go to the data marketplace to find weather data. So I could go to weather, I could find free data sets, and I can bring these into my environment very easily. I can click get data. I'm going to simplify this and just call it weather. And I'm going to make it public for everyone to see. Accept the terms and conditions, and that's it. It's all done. So if I go back to my worksheet and I refresh the page, you'll see that I now have access to this weather database. And all of these views that I have access to, I can query as if it's my own internal data, and I can combine it with data. And again, once I set up this share for the first time, I don't have to manage this to keep it up to date. When Weather Source updates the data on their side, I will automatically see that updated data in my environment. In Snowflake's new UI, we also have some light visualization tools. You can see I ran a query here and I got the results back. On the right, we have some light visualizations where I can do some data discovery and drill down. And I can also build out some visualizations. So here, I'm just mapping the number of trips per day over time. And I can change the bucketing. So I can do it on a daily basis or a weekly basis or a monthly basis.
It's cool.
And then once I've created this visualization, I can add it to a dashboard where I can now see all these visualizations that are pertinent to the city bike data on one screen. Thank you for joining us today for this demo of the Snowflake UI. If you have any...
Okay, yeah, it's pretty cool. I feel like it's very...
questions,
YouTube.
please check out our Snowflake documentation on our website. If you want to learn more, I would highly encourage you to check out our webinars.
For AI, let's see. Okay, because my thing is, all right. I am a tech company, or really any company. Let's say I'm a bank. Why am I gonna buy Snowflake for analytics? Okay, so I'm a bank and I want to see the number of loans I'm making in this year, or really any year in the past decade or two. If I'm JP Morgan, can I really fit all of that in an Excel file? Probably not, right? You're gonna have billions, okay, maybe not billions, but millions of rows, and an Excel file won't be able to handle that. Right? Yeah. How many rows can Excel handle? So million, yeah. So you can't physically just have an Excel file to do all that calculations for you, or to really build those visualizations. You need something that is very powerful, can process all of this data in a time efficient manner. So I guess from that standpoint, Snowflake does have a good selling point. I think this is also similar to Tableau in terms of the visualization stuff. And it's also a way that you can use I feel like it's a way you could probably use SQL in order to do this stuff. Okay, so my thinking is like, all right, you have a data center or a database. I guess this will help you select from different databases if you have different databases running. Like if you have a MySQL server, maybe a MongoDB, MariaDB, you can connect them all to the Snowflake platform, so you have this one centralized location for all of your data. With AI, I wonder how people can use Snowflake for an AI workflow. Because AI runs on data, right? But this seems like a mostly visualization thing. Maybe you take all of your data from the different databases, you store that in a data warehouse, and then from that data warehouse, then you just feed that into your network. Maybe that's the way. For AI. So data warehouse can serve as a staging ground, centralized location. Data that will be fed through a large a neural network / AI system, right? Could be. Sridhar, honestly. These two look very different.
Boundaries with nothing holding you back. And Snowflake is by your side. We're eliminating complexity and
our builders who are driving innovation and getting jobs done for organizations and startups across every industry around the world. And just like you, I love building things and solving problems. In fact, I recently wanted to write a script to remind me weekly which friends to get in touch with. And I used AppScript, Google's Gemini, and a spreadsheet to get this done. It was so much fun. So I feel a big connection to this community. And I want to thank you for being such a foundational part of our Snowflake ecosystem and for joining us today. We built the AI Data Cloud to make it easy for builders like you to innovate, develop, and scale. Today, the AI Data Cloud supports over 10,000 customers.
Okay, my question is, what the hell is the AI Data Cloud? I don't even know.
Across every industry
what
and
it
geography
means.
imaginable, from large financial institutions like Capital One to startups like Relational AI, who literally have bet their company on Snowflake's platform.
Oh, well, they actually
But the
have a
scale of the
website.
platform doesn't stop there. We are proud to support over 750,000 developers. And across our platforms, we see 5+ billion jobs run on a daily basis. That's a lot of people running and counting on Snowflake. And we keep reliability at the highest standards, 4 nines of SLA. And as data and AI are increasingly in the spotlight for companies today, a solid data foundation has never been more critical. However, so many companies struggle to deliver.
Okay, so I think what they're trying to say here is this is where Snowflake probably operates in. The warehousing. I don't know what OLTP databases are. I'll look that up. Online transaction processing is a database system that processes transaction in real time and stores them for later use. Okay, so I think that's probably what I was referring to with you have a database that essentially is taking things I got distracted, taking things in real time and storing things in real time. Could be events on a website, could be logs coming in. All of that is done immediately right after it happens. Database system.
For quality data and AI initiatives because their data infrastructure just can't keep up. Data infrastructure today can be like an old city's road network. It starts with a few simple paths, but over time, new routes get added without a clear plan. Suddenly, you have a web of winding streets, alleys, dead ends, Boston anyone, that make it difficult to find a direct path from one place to another. And some companies optimize for the short term and build departmental data marts. This leads to siloed and fragmented information. When you need a unified source of truth, the approach just does not hold up. Unmanaged data lakes and lakehouses can look promising, but the engineering overhead required to integrate different data sources is intensive, and security and governance problems pile up very quickly. We want to remove these challenges to enable a strong data and AI foundation that's easy to navigate. Our approach to deliver an enterprise-ready data and AI platform is grounded in three things. Number one, collaboration. We know that every enterprise needs to collaborate, sometimes cross-cloud, to get the information that they need.
Okay, I'm gonna create a build 2024 snowflake. End it on 4 minutes and 36 seconds. Stopping point. Okay, so we did learn a lot of information today, right? We learned about Elastic, their whole Elk stack. Now we're learning about Snowflake and their whole data cloud.
We make data sharing and collaboration.
Nice.
Our founders started with no
built on that architecture. And for us, it all starts with interoperability. That's the key to the
as the table format, Parquet as the file format, and we are committed to enabling engine interoperability.
And all you really want is for your data pipelines to be clean, on time, and governed. It shouldn't be complicated. 10 vehicle events every second. Inserting records into the iceberg table every 2 seconds.
This is some spraying going on right here.
Let's run the script and simulate events streaming into Iceberg. Excellent. With those records streaming in, let's switch over to Snowflake and select the table a few times so we can see the row count going up.
Okay, this is a notebook. Okay.
Great. One's the dynamic iceberg tables in our refined zone. So I mentioned in the beginning that this data needs to be governed. Analysts in my company shouldn't need access to the raw streaming data. They just need access to some tables. Let's look at the roles for Snowflake Catalog, and let's look at Table Reader All. Here you can see for the Spark Engineer role, I've assigned Table Reader All, which means that engineers can see semantic data models to automatically generate and execute accurate SQL to answer our question. And it looks like, on an average, Snow Tires outperforms all other suppliers in our network. Excellent. Now let's ask a question from one of our PDFs. What are the payment terms for Snow Tires?
Okay, so another chat.
That is why today we're extremely the right time to value for those trying to get new applications and for those trying. Our goal, our priority is to eliminate the friction of interchanging data products so that everyone in the ecosystem can get more value.
Conference.
We have one last announcement for all of you today. It's a couple of years ago that we introduced hybrid tables, the foundation of Unistore. Hybrid tables are a table type that unifies transactional and analytical data. You can do very low latency, fast reads and fast writes, and at the same time run a large analytical query on those tables, and you get the performance and concurrency that you expect. Use cases that we've seen is store state for a pipeline or store state for an application, which is an important part of native applications and collaboration. We have many customers that have chosen to not wait for this to be ready for production, and they're just using it. They found so much value. Here's a quote from Siemens: "With Unistore and hybrid tables, we overcome concurrency challenges and improve data quality and consistency for our critical ERP replication process." And probably similar to what I said with our notebooks earlier, one of the most common pieces of feedback is, can you please get this to be generally available as soon as possible? And today we are extremely excited to say hybrid tables are now generally available on AWS.
Okay, this is the strat.
And there's
Hopefully, my pay in San Francisco won't be that big, but if I can go to a bunch of these meetups and just eat all of their food, free food arbitrage, gonna try to make that happen. All right.
brings us to the end of this first session. We talked about data and architecture on your terms. We talked about enterprise AI and ML capabilities that you can trust. And we talked about
so that's
unmatched.
cool. I think from here, I'll probably just end the stream here. Yuki. Okay, before I do leave though. Yuki Kawamura. G League. Is it the Hustle, right? Memphis Hustle. So they play tomorrow. Okay. No, I'm surprised. Yuki Kawamura isn't on here. "13 assists. Oh, that's greater than number one. My 5'8" hero. Yes. Okay. So I want to say thanks for tuning in, guys. I probably gonna go eat some food right now. I'm kind of hungry. So, catch you guys in the next one. It's a weird way to end it, but I feel like we learned a lot. We'll try to stream maybe later. I'll try to see if I have some time. If not, it's fine. Alright, see you guys. Peace.